Welcome to The Explainer. Today, we are pulling back the curtain on a piece of magic that we pretty much all use every day, Netflix. We're going to figure out how it delivers movies and shows to your screen, like, instantly, and without that dreaded lag.
Okay, so let's just dive right into the big question, right? We've all been there. You're binge watching a new series, you hit play, and it just works. But what's really going on behind that simple click? Well, it turns out it kicks off one of the most sophisticated content delivery systems ever built.
So the secret isn't some giant magical server farm out in California. Nope. It's actually this really brilliant system that's built on 3 pillars. Each one is designed to tackle a different problem that could cause buffering. So let's break down how this whole hardware, logic, and delivery thing works together.
Our first pillar is all about the physical network. And this is where Netflix really starts to play a completely different game than most other companies on the internet. It all starts with the hardware.
This is the core idea behind something Netflix calls its Open Connect program. So, instead of your computer having to reach out across the entire globe to grab a movie, Netflix has already put that movie right there in your neighborhood. It's like having a global network of tiny local video libraries.
And here's where it gets truly genius. Netflix actually designs and builds these custom servers, they call them OCAs, and then they just give them to internet providers for free. They stick them right inside your local provider's data center, all in an effort to get that video physically as close to you as possible.
And we're not talking about just any old computer boxes. These things are high-performance machines, totally fine-tuned for one single purpose, shooting out video at incredible speeds. A single one of these storage appliances can pump out 200 gigabits of data per second and hold up to 120 terabytes of shows. Then, during off-peak hours, say 3 a.m., these boxes are busy downloading all the shows that Netflix's algorithm predicts your neighborhood is going to be watching.
What this all creates is basically a zero-distance effect. Because these servers are so close, a staggering 95% of all that video data only has to travel a few miles to get to you. It completely skips the clogged-up highways of the internet, which, is where most buffering happens.
Okay, but wait. If the video itself is local, where does the app live? Your profile, your recommendations, the actual play button, where's all that? Well, that brings us to the system's brain, which operates on a totally different principle and in a completely different place.
And this right here shows that perfect separation of powers. All the heavy lifting, delivering these massive video files, that's all handled by those local OCA servers. But meanwhile, all the lightweight stuff, like just managing your homepage, that all runs on Amazon's super powerful cloud platform, AWS.
So instead of having one gigantic, clunky program trying to do everything, the Netflix app is more like a team of over 1,000 little specialists. Each one is called a microservice, and each one has just one tiny job. There's a specialist for search, another for billing, even one just for managing your continue watching list.
And this is absolutely key to making the whole system so incredibly resilient. It means that if, say, the little service that generates movie posters has a glitch, it has absolutely zero effect on the service that's actually playing your movie. A failure in one tiny part will never bring the whole thing crashing down.
This whole philosophy of building for resilience leads to one of their most famous, and let's be honest, kind of radical engineering practices. They don't just sit around hoping things won't break, they flat out expect them to.
Yeah, you heard that right. They intentionally try to break their own system while it's live and people are using it. They have these tools with awesome names like Chaos Monkey that just run around their network, randomly shutting down servers. It sounds wild, but it forces their engineers to build a system that's so tough it can heal itself automatically, usually without any of us ever noticing a problem.
So, we've got the local hardware for pure speed, and we've got a resilient brain for stability. The third and final pillar is the smart stream itself. This is the tech that's managing your video quality in real time, right there on your own device.
Think of your Netflix app like a speedometer for your internet connection. Every movie is pre-sliced into these little tiny chunks, and each one of those chunks is saved in a bunch of different quality levels. So as you're watching, the app is constantly checking your internet speed and then asks for the next chunk at the best possible quality your connection can handle in that exact second. So if, someone in your house starts the microwave and your Wi-Fi dips for a second, it just seamlessly grabs the next chunk at a slightly lower quality instead of just stopping to buffer.
And it gets even smarter than that. They use AI to analyze every single shot of a movie. So a really fast-paced action scene, that gets a bigger slice of the data to keep it looking sharp and detailed. But a simple, quiet shot of 2 people just talking, that gets compressed a lot more because, less is happening on the screen.
This whole process optimizes every single second of video for whatever bandwidth you've got.
And the result of all this smart technology is a massive improvement that we can all actually feel. This combination of advanced encoding and that shot-by-shot analysis has cut those super annoying buffering interruptions by 45%.
So let's put it all together. Let's see how these three pillars really work in concert to give us that flawless streaming experience we all expect.
So when you look at the whole picture, you can see how each pillar is there to solve a totally different problem. The local hardware from OpenConnect, that beats internet traffic jams. The resilient brain built with microservices, that defeats software bugs. And the smart stream, that beats your flaky Wi-Fi signal. Altogether, they create this amazing multi-layered defense against that dreaded buffering wheel.
It's really an incredible system, you know? A hidden marvel of engineering. And it kind of leaves us with one final thought. As our appetite for higher and higher quality video, for 4K and 8K and more interactive stuff continues to grow, what new innovations are going to be needed to keep this invisible infrastructure one step ahead? What's the fourth pillar going to be?